So the first part about 7.5 is using and manipulating three important properties of logarithms in order to evaluate logarithms based on given information, to expand our logarithm, or to condense our logarithm. So let's take a look at what we've got for properties. In all of these, our base and our two numbers are going to be positive numbers such that our base is not equal to 1. Our product property looks something like that, and what it is, we're going to take our values of the individual logs and add them. Our quotient property, we see that our numbers are being divided, and our actual values for those numbers will be subtracted, with our numerator subtracting our denominator. And our power property, we have a number to another number. That exponent is brought out in front, and our logs are equivalent. You can go ahead and test this out with anything, like if we had log base 100, so that's 10 squared. That would be equivalent to 2 times log of 10. You can go ahead and try that out. It will work, and it's kind of the neat thing about these logarithms, they do always follow these properties. So, using this information, we can be given information such as log base 6 of 5 is approximately 0.898, and log base 6 of 8 is approximately 1.161 to evaluate the logarithms. Sometimes they'll be obvious, like here we see we are clearly dividing. So, as we talked about in the previous slide, if we're dividing, we're going to take our numerator value, subtract our denominator value, and when we do that, we get a value of negative 0.263, and we have our answer, and that's it. Once we figure out in what way this is a manipulation of the two numbers that we have, we'll simply add, subtract, or multiply if we have an exponent, and have ourselves our answer. So let's take a look at the next one. 40. Well, I know 40 is 5 times 8. So we know we're going to be using the multiplication property, which, as we saw, means that we're adding our two numbers. So I'm going to take 0.898 plus 1.161, and that equates to 2.059, and that's all I have for my answer. Alright, let's look at the next one. 64. Now, I know that 5 times 8 gets me 40, so that can't be it. But I look at 64 and I think, well, wait a second. That's 8 squared, isn't it? So, couldn't this be log base 6 of 8 squared? And in fact it is. Sometimes we won't use both of the numbers and just one of them in some sort of power or other manipulation of just that one number. So that means we're going to take 2 times our log base 6 of 8. So 2 times 1.161 gets us 2.322, and again, that's our answer. We will get into, in the later part of this section, the change of base formula, but since we don't have that yet, and we're given the approximations of what these logs are, this is all we can do to evaluate them. And our last one, log base 6 of 125. Now I look at that and I say, I can't really think of any powers of 8 that might help me, but I do remember from when we did all that stuff with powers that 125 is 5 to the third. So I'm going to take 3 times my log base 6 of 5, so 0.898, and I have myself an answer of 2.694. Now I do encourage you to actually look at, okay, well, is this actually what 3 times 0.898 is? And you'll see that it is. And a lot of times those are just like practice, unless it is the easy ones where it's just the numbers multiplied or divided that get you your new of number. We can also use these powers to rewrite or expand our logarithm. So I see there's a lot going on. I definitely have a quotient. So let's take care of the quotient first. Quotient I know is subtracting, so I have log base 7 of 3x squared minus log base 7 of 5y. And then in each of these, I also have a product. And then with my x squared, I've also got a power. So I'm just going to take it one step at a time. For you guys, you can easily, once you see everything, you'll probably be able to, after some practice, go straight into the final answer. But let's take a look. So I know that I'm going to have to do log base 7 of 3 plus log base 7 of x squared. I know I can't have exponents, so I'll get back to that in a second. And then I have log. Since I'm subtracting this product, I'm going to put it in parentheses so I don't forget about it. Again, that's going to be something that might trip you up eventually if you aren't careful enough. So I have log base 7 of 5 plus log base 7 of y. I've got that x squared to worry about, so I've got log base 7 of 3 plus 2 log base 7 of x minus, and I'll just make sure that that subtraction sign gets distributed throughout. Got log base 7 of 5 minus log base 7 of y. Again, eventually you'll be able to go straight to here, but I encourage you, as you're practicing the first couple, to just write it out long ways so you don't miss any steps. And the reverse, condensing. So using our properties, condense the logarithm. And since I see I have all numbers, I should end up with just a single natural log of some number. So let's take a look. I've got a plus sign, a number in front, so I know that's going to go back as an exponent, and then I have a subtraction sign, so I know that is division. So I know I have natural log of 8 times 5 squared divided by 10. I'm going to rewrite that for myself. I've got natural log of 8 times 25 over 10, which simplifies further to natural log of 8 times 25 gets us 200 over 10. And as our final answer, natural log of 20. So, clearly, a little bit difference, This one you'll have a longer answer. This one you'll have a shorter answer. Expanding and condensing, all using those three properties. It will take some time and practice, but until then, we'll practice in class, and I'll see you then.